All right, let's go over a few options that could be the reactant that you're trying to figure out. One thing I do want you to look at is the helpful tips on this page. If they help you to make sure you've met all these criteria for your explanation in the section before this, then go back and fix that real quick. You might pause the video, but make sure that you have multiple sentences explaining why you chose the reactant, explaining the conservation of mass, and using words like atoms, rearranged, mass, and product. You might pause this video, go back to the last section, and fix your last answer just based off of that. Now, we already know, you should already have this slide in your science notebook. During a chemical reaction, atoms cannot be created or destroyed. So keeping that in mind, what we're going to try and do, I'm going to go through my thought process on this and how I solved this problem. I went through 3 different kind of possible substances off of this list. My first one was I looked at hydrogen. I said, okay, hydrogen has those H's that could account for how they got over here on the product side. But then when I set this up, I'm looking at it and I say, oh, there's that sulfur atom. Well, the sulfur atom's not on the reactant side this way, so that can't be right. There's not enough types of atoms represented there. Then I also looked at sulfuric acid because that had sulfur and that had the hydrogen on it. So I put that one in there, I look at it, and then now I'm seeing there's some red atoms over here. Those oxygen atoms are not represented on the product side. So I know because of law of conservation of mass, whatever is over here has to somehow be represented over here. On the reactant side has to somehow be represented on the product side. It could go in reverse. Whatever atoms are on the product side also have to be represented on the reactant side. Again, we don't just wave a magic wand and atoms just don't disappear or poof, turn from like a frog to a prince overnight type of thing. It's chemistry. The last one I tried does seem to work though is hydrogen sulfide. If you put that in there, that accounts for the sulfur type of atom as well as those hydrogen atoms. And the chlorine atoms, don't forget about those. Those are already accounted for. So all the types of atoms are equal on both sides of the equation, not necessarily the amount, because we're not looking at, we might have several repeating groups of these different substances, but the types of atoms match from one side to the other. So that looks right to me. That must be what our reactant is. All right. If you need to go back and fix your answers, now's the time before moving on to the next section of your exit ticket.